Hi everyone, my name's Caleb. Our talk is called What's in Your Burrito, and we do apologize. It is not about AI, which I'm sure you've seen plenty of talks about. We're going to be talking about Kubernetes security. Why don't you introduce yourself?
Hey everyone, I'm Ronak. I also go by Ron. Work alongside Caleb at Chipotle, and yeah, let's get into this.
So to start off, a lot of the thoughts and comments we're going to make are our opinions. We're not necessarily representing our company, Chipotle, for this. So about the two of us, we started off as interns together at Starbucks in 2019. We have a lot of experience working in the quick service or retail industry. We worked as security engineers, software developers at startups, and then came back together to kind of start the application security discipline at Chipotle. A lot of what we've seen in the industry for the QSR space is it's very small, lean security teams. So our application security team is the two of us. Something we found that kind of goes along with that is the more you kind of get embedded with developers, the larger security teams have a lot of struggles. So we've found a lot of success by being very close partners with them. Something that is also interesting to note is we try very hard to not just go down control checklists. Everyone wants to kind of go through NIST 853 or similar checklists and go through the security controls there. And we try really hard to find the biggest bang for our buck because we're a two-person team and we can only get so much work done.
So that's actually a great segue for what we're going to be talking about today, right? So a lot of the lessons from running a restaurant at scale, like Chipotle, apply directly to how you secure a Kubernetes cluster versus a single app deployment. Things that matter the most end up being consistency, speed of delivery, what's actually going into your actual burritos, similarly what's going into your control paths. It comes down to how do we get the most out of our time commitments and make the most out of it. So that's going to be what we focus on this talk. We're not going to talk too much about self-managed Kubernetes environments just because there's some additional considerations when it comes to securing those. And since this is a cloud security talk, we're assuming you're using a managed provider like AKS, EKS, one of the many.
So one of the questions we want to ask ourselves is, do you actually need to worry about Kubernetes security? Obviously the answer is yes, but for your brand or for your business, you really need to understand what exactly is at risk, right? So for us, we're more worried about your customer data or the brand protection than necessarily the code, because our order stack is probably not too hard in the sense to figure out what exactly is happening in the back end if you are somewhat technical and can understand how APIs kind of work. So we really want to focus on the customer data, and a lot of that has to do with credentials and where you're storing credentials. It's something that you really have to answer for your organization, because we're not going to be able to tell you, if you're Home Depot or Lowe's, what exactly you're interested in. But for probably the QSR world, it's very important to protect your customer data.
So if you kind of just zoom out a little bit, and I'm sure all of you can totally read everything that's on this slide, but if you zoom out a little bit, Microsoft has kind of put together Kubernetes threat matrix, and this is inspired from the MITRE ATT&CK framework, if you're familiar with it. All it does is kind of breaks down what are the different tactics and techniques attackers are using to get initial access, escalate their privileges. It can all be very overwhelming when you start mapping out controls and map to each of these different threats. So as we go through this presentation, we're going to talk about the various controls that you can put in place, and we'll revisit this slide at the very end to see what really we can do to get the most out of our time commitment. So this is just kind of an interesting case study that we found, some great research from the team at Aquasec. This is from August 2023, where they analyzed a bunch of Kubernetes clusters that were out on the cloud for Fortune 500 companies, and they found about 350 had an open server that could just be hit from the internet. Some of you might find it a little bit silly because who does that? That's like 101. But it happens. Misconfigurations like this slip through the cracks all the time, especially when you're doing things yourself, especially if you're managing your own Kubernetes environment.
Something that we found a lot of success with is making sure that your Kubernetes cluster is behind a VPN or some sort of bastion host. And while that might sound to security practitioners extremely obvious, a lot of what we found with cloud teams is they're not thinking about that. They're finding the easiest path forward to stand up a Kubernetes cluster.
Cool. So what are we protecting, right? So as I said, there's lessons from running a business at scale that apply to how you secure a Kubernetes cluster. Some of the parallels that we've drawn as we've kind of worked through this are food supply chain. So when we are kind of thinking about how you spin up a new restaurant, you may have, you need to source your ingredients. And you need to be able to source your open source software. Same thing applies here, right? So these days you can't build an application without hundreds of open source dependencies. Similarly, you need traceability for those ingredients. So all the way from which farm supplies an ingredient to which region, you need to be able to trace that. So if there is an issue, you can react to it. Similar concept within Kubernetes. When you have an open source package that ends up in your environment, you need to be able to trace which pipeline it's coming from, which repository it's coming from, which image it comes through.
It's even more similar when you start thinking about some of the emerging trends as it relates to culinary. So obviously different regions are going to have different culinary expectations in terms of the food that you're providing them. Similar to software, right? We're going to have new malicious threats that are coming out. You're going to have new vulnerabilities because hackers aren't sleeping that are going to be constantly coming out. Same thing with the food safety guidelines in terms of they're coming out and saying, hey, you have to have food at a certain prep temperature, you have to have meats maintained at certain prep temperatures and making sure everything's super fresh. And the same thing with security standards, where we're always iterating on those standards in order to provide the best security for your organization. So what assets are we kind of looking to protect? A lot of our talk is going to be focused on the Kubernetes ecosystem, but we're going to drill into the SDLC because that's really where your security needs to start, right? So at the start, you're going to have your design phase where you're going to actually be going through and thinking about what it is you're building, why it's important, what the architecture looks like in any of the documentation. Then you're going to have to think about your local developer systems. How are you protecting your developers from downloading open source malicious packages? And then you're going to have the actual build system itself, where you're going to have all sorts of different controls, such as EPP or image verification, which we'll get into in a little bit.
And finally, you have the Kubernetes environment, right? So if you kind of break it up into components, as engineers like to do, there's really two things here. There's the control plane. And if you're using a managed Kubernetes environment, that control plane is opaque to you. You don't actually see etcd and some of the services running in there. And then you have your actual nodes that are running the workloads. And depending on the model, unless you're using Fargate, you're managing those nodes yourself. There's a bunch of services that are ancillary to this, right? So you have key vaults, you may have databases that all these services depend upon. So when we try to secure Kubernetes, we can't secure a Kubernetes cluster without securing all the stuff that goes around it and all the stuff that goes before it. So this is just kind of highlighting that all of these individual components have control points that need to be instrumented. So that gives us a good segue to jump into planning specifically. When you're planning on launching a new restaurant, what do you need? You need a few basic things. You need a test recipe. What are you actually trying to make? You need some test kitchens where you can try these out. And you need an audience that can try and give you some reviews. This may be as simple as your family is your test audience, and you have a kitchen in your home. It's as simple as that. Directly applies to how you plan software as well.
So the first part of our design stage is really the architecture. We want to help our developers out as much as possible. Because it's just the two of us, we can't sit in on every single meeting. We can't go through every single architecture review with them. So we really want to establish these golden paths so that way the developers kind of understand what it is they're wanting to build. We've had a lot of success with building out templates. So the hardest thing that we've seen in the SDLC pipelines itself is people wanting to put in controls, but they're wanting to put it in piecemeal. So if you build out templates, it ends up being essentially an import for the developers, so they don't have to think really hard about it. We also have had a lot of success because we use the same technology stack throughout our entire environment, we can build shared libraries for them or in conjunction with them, so that way they have a secure way of managing, say, a JOT or something similar like that.
Once you kind of decide on your architecture, it's a good time to maybe think about what are the threats you're introducing into your environment. There's plenty of threat modeling specific talks you can join over this week. So I'm just going to keep it super high level. basic idea is you want to ask yourself a few important questions. What is it that you're building? How are the data flows between those components configured? And then you can spend some time mapping out what are the individual threats, what are the controls you can apply for those threats, and then write some test cases ahead of time. This is going to be key because at the end of this entire development cycle, you can go back to those test cases and see whether or not you met your design goals.
So the next piece in the design stage that we've had working with our development teams is really documentation and making sure they understand what it is they're building, why it is they're building what they're building. In that documentation, you're going to be able to have kind of design sessions and make sure that we're building the architecture that you're going to want to use later for validation. We've also seen, I'm sure everyone has secrets that actually go into documentation, not just code, where developers copying and pasting from their code base into their documentation. So you want to be able to scan your documentation for any secrets. And then the final piece is having a dashboard tracking all of the work that's going on. We have a bucket that we call SSS. It stands for security, scalability, and supportability. And we tag all of the requests that we make and then have a dashboard that pulls all of this up so we can track exactly where in the pipeline in terms of work it is.
So these three components that we touched on, architecture, threat modeling, as well as the documentation that goes along with it, kind of summarizes really into a few important questions before any dev work begins. I think we recently were just chatting about a feature. Caleb, do you want to kind of just talk about what is the goal of what we're trying to build?
Yep, so we had a feature come through where we're designing multi-factor authentication for our services for logging into our accounts.
Okay, so at this point, just for illustrative purposes, what you may think about is what are the different components that are going to need to be stood up for this?
Yeah, so when we're thinking about the different components that you're going to have an API backend service that might be touching a customer database. You want to make sure those are all secure. And then likely you have a third party, for, in our case, a third party that you're sending that 2SV code to that's actually going to be pushing it to the customer. And in all those cases, you want to secure each component, but you need to understand what it is that you're going to be securing. And that's where the threat modeling and all the documentation and architecture comes into play.
Cool. A lot of what we're going to talk about will kind of circle back into this.
So for the build stage, we make a lot of parallels with the restaurant for this. If you've ever gone into Chipotle, they open at 6 in the morning. They're doing all their in-store prep and making sure that the food's ready to go. So we draw these parallels with that, as well as the food supply chain. So everything that you're building has some sort of open source component to it. Especially these days, and there's all sorts of threats that are coming out of that.
Before we kind of talk about the pipelines, I think it's important to understand what it is your pipelines run on, and your answer may be slightly different. No matter what you use, whether you use GitHub Actions, you're using Jenkins, Azure DevOps, fundamentally there's two models. You have a managed builder, where your cloud provider or your pipeline is managing those actual nodes your pipelines are running on, or more likely you're using a self-managed host. So under the hood, they're VMs, and because we're going to secure our Kubernetes environment in a way where the only point of injection remains is your build pipeline, this becomes extra important to secure and lock down, because this is going to be a super easy way for attackers to get in. And we've kind of seen some recent example in news recently of people abusing this. So think about EPP controls, audit logging on these build system. How are secrets being vaulted for them? What are the network connections that you can make out? Does it need to make out all those network connections, or only specifically to where it's doing the deployment? So it's important to kind of consider the system itself.
The next step is obviously securing the pipeline. So in your pipelines, we're going to go back to the templates that we talked about a little bit ago, but you're going to want to make sure that you have your common SCA SaaS tooling in there to find any of the vulnerabilities that your developers are introducing. But we've also had a lot of success talking to them about end-of-life software, which is really just deprecated software that no one's maintaining anymore. And oftentimes this means that the end-of-life software is replaced with either a new package version or an entirely new package on its own. Another key piece of this is image signing. This is something that we've been trying to talk to the vendors that we use about. So any Docker image that goes through our pipeline gets signed by an X509 certificate. It's basically just proving the authenticity of that image that's going through our pipeline. So that way at deploy time, which we'll get into in a little bit, we validated that anything that goes into our Kubernetes cluster is actually signed by us. Another, I think, piece that not everyone thinks about too hard is a Docker image as a base template. So we're very fortunate that we use the same base image everywhere, which is just a .NET image. And that allows us to actually essentially create a Chipotle-specific image where we do patch management. Since your Docker images are constantly riddled with vulnerabilities, since they're just Linux under the hood for the most part, a lot of our developers don't really understand how it is that patches happen for your Docker image. And some people think it's, oh, to just rebuild your Docker image, but oftentimes Microsoft hasn't released a patch for specific vulnerability that's come out over the last hour or 2 hours, and then we're breaking their builds depending on how the severity of that Docker image.
And sort of the last piece here, and this kind of goes back to just reinforcing the fact that we're locking down our cluster, and this means our pipeline is our point of injection. What are the identities that can do this? So typically you are using a service account to do the deployment from your pipeline, but you also need to kind of abstract that and think about what are the different identities and what specific namespaces or clusters they need to deploy in. It's important to have that least privilege. It's just, you know, security basics here, but it kind of gets lost in the layers of obscurity here just because it's not as evident. So it's important to kind of think about what are the different roles you have within your build systems and what can they do in your cloud environment.
So now we're going to talk a little about the open source supply chain. One of the things that's kind of rolled out over the last year is the OSF scorecard. And what we've tried to do with our development teams is anytime they're pulling a new package, and it might not always catch everything, but it's going to give you at least a good baseline of what's known good. We'll have our developers go look and see if they have this OSF scorecard and see kind of what the grade is. We have some tooling that we've ran that actually goes through and looks at this open source scorecard and gives us some policies around what exactly that score has to be. So we try and keep things above an 8, and so that way we know that the package that they're pulling in is actually good. Some of these other kind of typo squatting and malicious base images are different types of attacks that we've seen in the wild that our developers might be, 1 in the morning trying to pull a hot fix for like a Python library for requests, and they might mistype requests, but now they have a malicious version that acts the exact same as requests it would, but it's actually phoning home to a CNC server. And then we've all heard about the XCutil attack. So you'll have someone that's masquerading as a bad user, or as a good user, sorry, and then actually being malicious with it. We'll talk a little bit later about Docker images that kind of go through that same thing.
That brings us to sort of that deploy time. So what this means in a restaurant is your checkout area, right? So kind of final check on accuracy and quality. It's your opportunity to include any sides that the customer may have requested, adjust for missing ingredients, cater to any special requests. What this means on Kubernetes is our admission controller and any cloud policies we have configured that adjust the resources to match with our baselines. So just to kind of zoom in a little bit, as practitioners, you may not totally need to understand all the details here, but what's important is when you hit that deploy, or in your kubectl, you deploy a workload, what it's going through is an initial auth check, make sure you have the permissions to deploy. Then there's 2 admission controllers that are running. There's a mutating admission controller that can make slight modifications to your YAML based on a Rego policy you define, and there's a validating admission controller that can validate based on policies you've defined. There's built-in plugins that Kubernetes provides that you can just enable for these admission controllers, but they also have a webhook where you can deploy your own server, and that's a lot more flexible, where you can write your own Rego language. If you're familiar with that, that's just a policy engine language. You can write your own web server that will handle these requests, validate what deployments are going in before allowing them into the cluster.
So what really are we looking for with this validating webhook? We have an agreement with our development team that they do not have a shell or root access. So we're validating that we have all these configurations taken care of. As Ron mentioned, with Rego policies, you can define anything that you want really with them in order to determine what's going into your cluster. So we'll fail a deployment if any of these policies are misaligned. It also allows you to kind of, and this is something the mutating webhook can do, but change the compute and memory limits. But we have a policy within our cluster that you can't deploy with too much compute or too much memory allocated to a pod, so that way they're not having a runaway pod in their environment.
Something else that we can do here, so obviously in addition to catching misconfigurations that we don't want in our cluster, is actually build a risk profile. So the way to kind of think about this is, what is it that I'm adding into my environment and how does this change the overall risk of my cluster? So what kind of container privileges does a specific workload need? For example, you may have a monitoring tool that requires access to NetRaw capabilities because it wants to see all the traffic that's going over the network. And that might be an exception you add to your policy, and by default you may not allow all your resources to be able to do that. Similarly, you can define Linux security modules, AppArmor, SE Linux, depending upon the distro of Linux you're on, and seccomp. And what this will allow you to do is limit specifically which kernel level calls can your container make. So for example, if you don't want access into etcd at all, no matter whether you're root user or whatever, you can define an AppArmor profile that will block that. There's default profiles that do limit it to a good amount, but as we've already seen, there's container escape vulnerabilities that pop every few months, and really what you can do is define a custom profile for each of your application. Lastly, you have a set of account privileges. So again, going back to that identity plane, when you think about specifically what your workload is running as with service account, those service accounts may have inherited permissions into your cloud environment. So being able to read specific storage accounts, being able to access specific databases, you can add this into your overall risk profile for the application.
So now we're at the image verification piece. We've gotten past the admission controller, webhooks for validating your risk profile and all your different configurations, and now it's going to validate that it's actually gone through all of your pipeline checks to make sure that it gets into the environment safely. We try and do this with not only our first-party images, but also any third-party images. So we do all of our scans on those images as well before they go into our environment, and this just allows us to make sure that everything is up to snuff, in our opinions. A lot of custom kind of common attack paths that we've seen in the wild are someone getting a real image in that's gone through your pipeline and then trying to deploy another image that they're pulling. The admission controller will block that because it hasn't been signed by your image verification process. So vulnerabilities, these are probably the worst thing in the world for everybody that's a security practitioner because there's constantly new vulnerabilities coming out. We have, as part of our policy for the admission controller, no criticals can actually be deployed into the environment. They have to be resolved. This doesn't often work with a lot of your development teams though, because they spent potentially weeks, maybe even months working on a feature that's gone through QA and it's using the same build image. And by the time it gets to production, a new vulnerability's popped. And so they have to go rebuild and redo the entire process. And so what we've done, instead of kind of scanning vulnerabilities during the pipeline at deploy time, we scan the container registry itself. This gets you a lot further ahead, so that way you know what exact vulnerabilities are on all of those images that are kind of just sitting there.
So that brings us to monitoring at scale. So now that we are actually looking at our ACR, that's one component of it, but looking at this from the restaurant lens, typically the way a large chain would operate is they would have restaurateurs that go into each location, check for consistency across them. You want to have the same experience at a Chipotle in New York as you would in a Chipotle in Arizona. You need to make sure that that consistency is always present. You want to make sure you have inventory for your critical ingredients. You can't really make a burrito without a tortilla. So you want to make sure you always have that consistency. And lastly, you want to monitor for reviews and feedback, and this is kind of the loop that most businesses go through. Same directly applies into software as we'll kind of zoom in. Specifically when it comes to Kubernetes, the way you can do runtime monitoring is through an eBPF sensor. Extended Berkeley Packet Filter is what this stands for. What it does at a fundamental level is it sits on your kernel. It's a program that sits on your kernel and looks at what kernel calls are being made. You'll talk to many vendors that operate in the Kubernetes runtime space, and under the hood, they're likely using the same technology. So it's kind of important as a practitioner to understand what this means for your environment. Some of the things that you can do with an eBPF is not just monitor what kernel calls are being made, but actually react on them. So you can actually use this to protect yourself against, typical backdoor attacks. You can monitor for runtime events, API calls that are being made, and sort of define your own policy based on that.
So as we talked about with kind of continuously validating your ACR, it's really important that you actually have a handle on what is sitting in your ACR as well. So you want to scan for all the vulnerabilities there and then really understand kind of what that risk profile for your business looks like. We don't allow highs or criticals into our environment as much as possible, but it's really important for you to understand. Sometimes a high may pop on a shared library that you have to go resolve, but it requires a lot more than just updating the package. It may require changing the actual parameters that are going in. So you have to make sure that you're continuously validating this for any testing that may happen. External attack surface monitoring is another really important piece. You want to understand what it is that's on the public internet. Obviously, we hope that your Kubernetes environment is not on the public internet, but you're going to have all sorts of other storage accounts, key vaults, databases that may be sitting on the public internet, and you're going to want to use some sort of external attack surface monitoring to validate that. The final piece of kind of this continuous validation is understanding that your controls are everywhere you think they are. It's really important that you know that your SaaS tool is running against every single repo that's being built, or that your SCA tool is scanning all of it. Sometimes we've seen where your SaaS tool might be running, but you don't have a way to validate that it's actually working. It might say that it's working and passing all of its checks, but you need to make sure that you're proactively getting in front of that, because your dev teams aren't necessarily going to be monitoring it. They're just going to say, hey, my pipeline has a green check mark next to it and it passed and it's now able to be deployed. But it doesn't necessarily mean that your tools ran. So it's super important to make sure you're proactive with this.
And lastly, you have the overall Kubernetes posture. So now that we've kind of come to the deploy time, we've come to the runtime, we had discussed a few things during the planning stage, and now we need to make sure that that's held true. So some of the things you may see in this space are posture assessment tools. What these are looking for is against a compliance standard like your pod security baselines, like I think it's called the PSS standard, or CIS controls. These posture assessment tools are really just validating that you're following best practices within your environment. A second important piece of this is understanding the architecture that you had defined initially is being held true. Typically, when you're trying to meet deadlines, you may take one or many shortcuts to get there. And as security practitioners, we need to understand what is the cost of taking those shortcuts, what is the opportunity cost that we took to get here. So it's important to understand that with architecture assurance, you kind of want to think about how you have separation between your workloads. So just to kind of abstract that up, if you have applications deployed into different namespaces, are they communicating with each other? Are they only communicating with the applications they're supposed to communicate with? Or do you have some sort of a misconfiguration that slipped through the cracks? This kind of boils back into the data level, because ultimately what we're trying to protect is data. So it's important to have clear data classification and understanding what is the lineage for each data element. So from a source system that it's being collected, let's say your website, all the way to the exact database it's being stored in, you should have some form of traceability to understand how it's flowed through your environment. So in case you have to, for example, react to a data issue, you're able to see exactly which systems it may have touched on the way. Sort of that last piece of the overall posture is going to be identity once again. What are the different machine accounts you have defined in your Kubernetes environment? What is the RBAC policy on them? And what different network access they have within your environment? So there's been a lot here. How do we prioritize? So specifically, when we talk about what we're talking about here, there's a lot of different control points we've seen. We've seen some in the plan stage, some in the design stage. Not all of them are going to give you the same value for your money. We want to kind of double down on what gives us the best bang for our buck. So just to kind of start off, what you want to do is understand what's at risk for your environment. And this means identifying the sensitivity level for various workloads. Not all of them are going to be equal in your environment. Maybe the Kubernetes cluster just handled some, secondary data and you don't really care that much about it. That's something for you to assess as an immediate next step. Understand what's the current state. You're likely not coming into this greenfield. You may have some SaaS tool in place. You may have some SCA tool in place. Think about what controls you currently have in place and how they impact your environment. It's important to kind of abstract that up because generally as an industry we say SAST and SCA and ASPM because it helps us bucket these tools. But fundamentally the way they operate may be different and the capabilities and the threats they cover may be different.
So like we said, we were going to come back to this Kubernetes threat matrix. All of these ones that are highlighted in yellow are common attacks that you've been seen in the wild. So it's super important that you kind of understand that all of these controls that all of these tools that we're going to talk about over the next few slides, they cover a lot of these common attacks. A lot of the controls we've talked about also help you validate that you're safe from these common attacks. So there's, I think, 20 highlighted in yellow, and I think the total number of Kubernetes kind of controls here is closer to 40. So as you can see, you get half of that just by implementing these kind of basics.
So it's when we look at all these threats, there's some controls that cover many of them and provide a lot of coverage to us. So as you might expect, images are the base of all the compute that are running in your Kubernetes environment. So the security of those images and the integrity checks we do to make sure they're coming from our trusted pipelines is going to help mitigate a lot of escalation attacks from that previous threat matrix. Similarly, external attack surface monitoring, this is just a security staple for a reason. Things evade our pipelines. We can never control everything that's going into our cloud environment, and having some form of continuous assessment of what's out there gives us a lot of value for our time. Runtime application monitoring and filtering is another one. This is very similar to how your EPP tool might operate. It's doing detection and response. It's seeing what's actually happening in your environment, and you can define response playbooks to react to it. And then there's a couple of security basics, right? So we keep coming back to IAM, and that's for good reason, because about, I would say, 5 to 10 of the highlighted yellow threads that have been observed in the wild can just be solved by having strong IAM policies. And I'm using this acronym a lot, so I'll just make sure I'm clear about it. Identity and access management. Having good identity policies will go a long way in preventing a lot of the Kubernetes attacks we've talked thus far.
So the next few slides, we have listed a number of tools that we find super helpful in terms of solving kind of all these different control points. So at a high level, templating is really important. As I mentioned at the beginning, if you have templates for your developers to utilize, they'll be able to implement a lot faster. So the next 3 tools that are listed there, Notation, Grip, and Zeal, are all different tools. Notation does image signing, Grip generates an SBOM, and Zeal does end-of-life detection. And if you're able to put all of those into a template that your developers can consume, they don't have to think about what it is that's running in their pipeline. They may have to think about, oh, my pipeline's running 2 or 3 minutes slower because you've introduced some new tools, but that's really all they have to think about. And then the emission controller. A lot of what we've seen with emission controllers, whether they're built by a company such as Wiz, or if they're built by open source, they're all using Rego under the hood for just policy generation. So Gatekeeper is a great open source version of an emission controller.
In terms of posture management, there's a couple of tools you can use to get started. Kubescape is a tool that will help you with both managed and unmanaged Kubernetes environments, just to understand what your overall posture is and how your controls map to them. MCAT is a tool by Datadog that specializes in managed Kubernetes environments. External attack surface monitoring is a whole complicated beast, but the project by Project Discovery, they have a set of tools you can orchestrate in your environment. It's all open source, all free. You can use it to kind of understand what your attack surface is, understand what endpoints you have out on the internet. And lastly, for network policy, defining the service mesh within your Kubernetes cluster, you can use Cilium or Calico. Both of these fundamentally will work in a similar way. What you're defining is what can a specific application talk to in your cluster.
So now that we've kind of introduced these tools that are, we think, critical, the next step is kind of running down to the road to maturity, where you're going to have even more kind of advanced tooling, you could say. So one of the ones that we found some good success with is any IAM review. So as Ron has mentioned a number of times, identity really is the most important part of your Kubernetes environment. Something to kind of think about is how many service accounts do you have within your Kubernetes cluster, If it's 1, that's kind of horrifying. If it's 50, that's horrifying, but in a completely different way. So it's really important to kind of understand what identities are actually able to do within your cluster. And then you kind of get to the runtime monitoring using eBPF sensors. So Falco is a really easy to use open source container runtime monitoring, and it's just running as an eBPF sensor, and you're really able to kind of generate policies around it in order to block common threats.
So another acronym here, industry just loves acronyms. LSM profiles, Linux security modules. Briefly mentioned it earlier, AppArmor, SE Linux, and SecComp. It's a little bit complicated to actually implement at scale. Default profiles will get you a long way, but if you're really trying to mature your security posture, Inspector Gadget is sort of a eBPF toolbox where you can plug in different eBPF tools to do different things. One of the things it can do is actually profile your application and give you a recommendation on how to build a hardened SecComp profile for your app.
And then we'll kind of just, the developer golden pass you really have to introduce with your teams. We have come together with our teams and have a lot of agreements with them, but we have really good relationships with the leaders over the application development teams. So if you don't really have a great relationship, it might be a little harder to get some of these golden paths in place. So it's really important that not only are you building good security practices within your own organization, but you're building those kind of key relationships. For the architectural assurance piece, we found that Namespace Hound does a really good job of kind of telling you what the namespaces is that different containers can talk to. So it's not only you want to, if you're deploying a Kubernetes cluster, all of your namespaces that are in there, you likely don't want namespaces to be able to talk to each other unless it's for very specific cases. So we've kind of used Namespace Hound to map out exactly how our namespaces are laid out. Especially as you start getting in bigger Kubernetes clusters, you may have 50, 60 plus namespaces, and that quickly becomes a beast. So.
Well, thank you everyone for joining. We'll take some questions if you have any. I know we're a little short on time. It ran a little bit longer than we wanted, so we'll try to answer as quickly as we can.
Yep.
Yeah.
Thank you for the presentation. In my opinion, monitoring is one of the most important items in this architecture. Also, you mentioned that. But in Kubernetes environment and pods generates million line of events, and analyzing that events and monitoring these events needs to correlate with security perspective. Do you have any experience about this topic, and how can we correlate, or how can we exact the right suspicious events, detect suspicious events with these logs? Thank you.
If I got you on the question correctly, you're saying you have all these runtime events coming through. You want to understand how you can do, how you can analyze them and understand threats that are emerging in the environment. Okay. So I would kind of separate architecture assurance from runtime monitoring in this case. You're specifically going to get value from architecture assurance and really kind of going back to that original threat model and understanding what that resulted in your runtime. Runtime monitoring will give you exactly, I think, what you're looking for here, which is events generated in your environment, what they link back to, and what they might mean. So that's a little bit of anomaly detection and a slightly different use case, in my opinion, than architecture assurance.
Okay, thank you.